Have you ever sat and stared up at the stars and wondered, where did we come from? Let's take a journey like no other, not to a place, but to a time. Join us as we delve deep into the human past and explore our shared human origins. Welcome to the world of paleoanthropology.
Hello, everybody, and welcome to The Story of Us. I'm not used to saying that as it's the new name of our show, but I'm very excited. Today we have a very special guest. I will allow her to introduce herself.
Hi, my name is Dr. Ellison McNutt.
It is very nice to have you on, Dr. McNutt. How are you today?
I am very good. How are you?
I am wonderful. So glad to have you. So, I think one of the most exciting and biggest reasons that I really wanted to talk to you was because of this paper that you recently published. Why don't you tell us a little bit about that and what the main focus was?
Yeah, so this paper is really exciting, kind of re-looking at a fabulous site in Tanzania called Laetoli. And what makes Laetoli really interesting is the fact that it's about 3.66 million years old. Volcano exploded, threw down a bunch of ash, which turned to mud, and then there are thousands of footprints of a bunch of different species of animals that have been preserved in this ash mud layer, including several really fabulous bipedal prints, so walking up on two legs, the way that humans do and move through the world. And there are two of these footprint tracks that belong to bipeds. One is the very famous fossils, trackway G, which most people believe belongs to Australopithecus afarensis, the same species as Lucy, the quite famous fossil. And then there's another one that was a little more recently discovered in 2016, and that's called trackway S, and that most researchers also belong to Australopithecus afarensis. But this paper was looking at actually a really cool site, trackway A, which was actually found first. It's about 2 years. It's in 1976 when it was really discovered. G was found in 1978. And these are really odd prints. They're odd bipedal prints. They don't quite match up. Certainly didn't match up with the fossils that were there at the time. And so when they were originally discovered, they sort of, how do we explain these kind of odd things going on? Well, maybe they are a bipedal bear, which isn't actually all that unusual. You may be kind of thinking bears in Africa. Bears do exist. They were in Eastern Africa about that age. And they do walk upright, right? So when you ever see a bear stand up and walk on two legs, you're like, was that a guy in a bear suit? Like sometimes it has that kind of moment. So it was kind of a reasonable thing, but then they found G a couple years later. They're beautiful. They really match anatomically well with the fossils we had from Afarensis. And A kind of fell off the radar for our field. And then I was working on my dissertation at the time, and I was really interested in bears because bears are a really cool analogy with apes. So I'm interested in understanding the evolution of human locomotion. Why do we move the way we do? Kind of how did that start? And one of the ways we use to do that, because obviously we're kind of the only name in town for living hominins, is comparative anatomy. So we look at other animals who move in similar ways, both ones that are closely related to us, things like chimpanzees or gorillas, and things that are distantly related to us, like bears, who have some similarities in their locomotion to kind of understand how your motion shapes your bones, and that can help us interpret fossils. So I was into bears because of the work I was doing in my dissertation, which I'm happy to walk through more of. And then I heard about these prints. I sort of came across this research of the early discovery of them and kind of was a little like, I don't know that I buy that there's a juvenile bear walking by itself for these five prints in this place. And that sort of prompted this rediscovery. Happened to be working in at Dartmouth, where I was doing my grad program. Just down the road is a fabulous American black bear sanctuary called the Killam Bear Center, run by Dr. Ben Killam. And so we had this opportunity. One of the things they do is take in orphan black bears. So we had little black bears that are the size of these prints essentially, and said, all right, let's have you go walk and see what you look like. And do you match? Does this make sense? Can we actually test this hypothesis that just kind of sat there for a long time? And then they don't match. And it sort of prompted then a deeper dive into those. And then also going back and actually re-excavating those prints, and kind of getting a better sense of them. They hadn't been fully excavated the initial 1970s. So this let us kind of see some anatomies that were critically missing when they first made the bear hypothesis, and kind of let us come to the conclusion of our paper, which is that not only are they not a bear, they're definitely a hominin, and it turns out they're also inconsistent in some pretty important ways from those other two bipedal trackways, making them really unlikely to belong to Afarensis. So this is the second hominin species walking around at the same time, just shy of 4 million years ago.
Which is amazing and just helps prove and show to us that there were so many different hominins at one time in one location, which I think is a key part of your paper as well,
Yes.
showing that, which is just amazing because it's so hard to find that, exact like trace fossil evidence of, wow, they were actually here, relatively in the same time, kind of, yeah.
Fabulous thing about footprints. Our fossil record has several sites both in eastern and southern Africa where we have places where we've found fossils that belong to multiple different species of hominins, but the nature of our fossil record, those are going to cover pretty wide swaths of time. And so the cool thing about fossils, when they're footprints like the Laetoli ones are, these are made on really short time scales. We're talking like hours to days tops. So these are definitely two individuals, the folks who made A could have looked across the landscape and seen an Afarensis, and that is a fabulous and sort of unequivocal moment of two hanging out, which we haven't really seen that distinctly anywhere else in the fossil record.
Most definitely, and that's just amazing. Now, as far as the tracks actually go, do you know why, or is there a reason they weren't originally completely excavated in the 70s?
So no, some of it is probably about the nature of field seasons. When do you go? And so they'd gone, they'd found these, got into, and then may have had to leave and then come back. And then when they found G, those definitely captured the major attention because there are so many prints there and they are really well preserved. And our fossil record, to their credit, our fossil records changed dramatically, particularly in terms of lower limbs and our understanding of how many different species existed, how much diversity there was in ways of moving through the world. So it was a more Spartan field when these were found in the 70s. And so when they had a really nice match with an anatomy of a fossil from that area for Afarensis, they're sort of like, okay, these are the focus, and these ones that we don't quite know what to do with, they just weren't as much of a priority, and that has probably played a role.
Makes sense. Now, as far as, of course, there's no way of knowing this, and I mean, there's no way of knowing even the Afarensis footprints for sure, but based on what we have in the fossil record, are there any speculations as to what species this might be, or is it just completely unknown?
So yeah, it's one that we can't give like it's this for sure without more fossil evidence, and that's partially because even the sort of other players that are walking around the field at this time. So there's things like Kenyanthropus platyops, Australopithecus diremida. We have the Laetoli foot, which although the Laetoli foot anatomically doesn't match well with A, so that's probably unlikely. But in terms of Laetoli, we don't actually know what species that goes with, and so a lot of our problem is we have fabulous cranial material telling us we have these different species, but we don't have any feet from them. Or something like Laetoli, we have a fabulous foot, but we don't know who it belongs to. And so we have lots of pieces on the field, but until we have a few more parts of the puzzle, it's really hard to put exactly together. But certainly something like those animals, Kenyanthropus, Australopithecus, or possibly an unknown still, are certainly possibilities for the makers of Laetoli.
Amazing. And, you know, when we're talking about, why don't we discuss a little bit how these fossils are created? Because typically when someone thinks of a fossil, they think of bone, obviously. So what creates a footprint fossil, a trace fossil?
Yeah, so they're odd because they're so ephemeral and sort of how does this end up sticking around? And it sort of comes down to this sort of unique moment at volcanic activity. So the volcano exploded, then laid down this ash layer, which is really helpful because the nature of the ash is that it's datable. So that's one of the ways we know how old these prints are. We know that those trackways, despite being a couple kilometers away from each other, are part of the same age, same situation. And then fairly quickly, so a bunch of animals walk across mud, make typical footprints as you might expect, and then they get covered again by another explosion can throw in another layer of ash, excuse me, and so they have to get buried relatively quickly because otherwise, if they didn't, sunlight, seasonal rains, the walking of other animals would walk across them and crush them. So they ended up getting kind of sandwiched between layers, and that holds and protects them. And so then when they were discovered, part of the way that they were discovered is the action of those erosion forces kind of essentially tore off the side of the hillside and exposed that layer that has the fossils in it, the fossil footprints in it. And so then you sort of lucky researchers, actually that's kind of a funny story about how they found it. I'm sure you've heard this. A
Yes,
dung
I
fight.
know. Yes,
Hitting the
exactly.
deck
I'm
to
sure we'd
avoid
love
the
to
dung.
hear it. Yes.
But it's sort of like cool moment of science of like, you have to be in the right place at the right time to catch them, because if hadn't done that, maybe they'd gotten exposed and then they'd have gotten an elephant walk
Mhm.
across them and stuff like that, then be destroyed. So fossils are an amazing and a frustrating thing to work with, because they're hard to get created. And the things that get into circumstances where there might be fossils, you have to find those fossils, you have to find them before they're destroyed. Like, so the chances of
Right.
all the things that were alive that could be a fossil, you end up with a pretty small thing. And footprints are especially that way, because the chances of this little snapshot getting buried quickly enough to preserve them is unusual, and so we're sort of worked out because of the activity of that area.
That's a wonderful way to explain it. Now, I wonder today, now obviously, as you were mentioning, erosion continues to happen. So is there any effort, or are there coverings, or is there something preserving these prints? Or are we just
Yes.
relying on casts?
So no, and that's one of the things. Our team, and certainly one of my colleagues is Dr. Charles Masiba. He's one of the main researchers at Laetoli, often leads field studies there, and it's one of the things that he's really concerned about is how do you preserve these footprints, because they're not like we can just take the bone out of the ground and take it to a museum and preserve Lucy in that way.
Mhm.
But whereas footprints, trying to remove them from the ground would often probably destroy them. So how do you keep them safe? And so one of the big concerns when we started looking into Laetoli A is that we couldn't actually find any casts. Casts were taken of the originals when they discovered them, and they probably still exist tucked in a corner somewhere, but we tried our best to track down any of the people involved and couldn't find them. And so then we went, oh gosh, what if they weren't reburied? And it seems
Mhm.
likely that they weren't. And so 40 years of rain may well have destroyed them. And what we got lucky with is the 40 years of rain instead dragged the surrounding hillside on top of them and reburied them.
Mm.
And remarkably, being buried under the does what it did for almost 4 million years and kept them really, really well preserved. And so now, after we finish our excavations, a couple things, we then used some technology to try and ensure that we at least have a good record of them. So we did photogrammetry. So take lots and lots and lots of digital photography from very specific angulations and things, so you can help reconstruct 3D models of that. And so those are available on Morphosource. I don't know if you're familiar with that, but it's sort of a hosting site for research related materials. And we also did 3D surface scanning. And so we also made those scans sort of to try and protect them in perpetuity. But then we also, when we finished our excavations, reburied them in the same
Okay.
sediments locally. That is one of the things you got to be careful about, sort of if you bring in sediment to cover them again, if you bring in something that has plant seeds or things like that where
Mhm.
they're going to grow through the prints. So we use the same, it's not exactly sterile, but the same material that
Right.
was already around, sort of hopefully to try and minimize some of that, and reburied them, remarked them. It was one of the things we had to do was as a team was go find them again, because there wasn't any indication about where they actually were. We were fabulously lucky though. When Mary Leakey and her team in the 70s actually found these, they took these amazing notes. They created these maps, not only of the hominin trackways, but of the surrounding animal prints.
Mm.
And so we were lucky enough, there's a set of elephant prints that are relatively close
Right.
to Laetoli
Right.
A. And so we found one of those prints of the elephants and were able to actually trace it back to find the A prints. So, yay for good note taking. But
It's
then
definitely.
we've now marked it. We have GPS technology, things like that, so it's much clearer now about where these are, and should they need to be excavated again for some reason, or for another team to come look at, it should be much easier to track them down.
Well, that is definitely a great thing. It sounded like for a little bit it was a bit of a detective story there.
There was a little concern.
Well, definitely. I mean, that's one thing, I always wonder, as not even just as an anthropologist, but as a human, how much of our history has been just lost. you know? And it's just, glad to hear certain things are able to be preserved in that way in their natural setting in situ and everything. And it's great to hear.
It's a weird thing. Humans are both have certainly the capability of being destructive, but we also have this innate thing of like, I just want this cool thing to exist. Like there's I don't know a lot of the details about this, but there's a cave that has these fabulous crystals in it. That was a
Mhm,
flooded cave.
mhm,
They emptied it to
mhm.
look at the crystals and then realized the crystals were being destroyed. So they reflooded it. It's just because we like knowing it's there. And it's cool and it's part of history. And then we like knowing about the world. I think it's one of the innate kind of curiosity of people.
Most definitely, absolutely, most definitely. Okay, so now that you've found them again and you've analyzed them and you've discovered that it's probably not effort, well, it's not effort,
It's
you
not
can pretty much
efferensis. Yep.
say. Um, what's next?
So the next thing is quite rightly some folks, and this is the nature of science, and we welcome this, is that it's a collaborative effort. People say, well, maybe I don't buy that it's a bear from this, and someone comes to look at it again. And some folks here have been like, well, how do you know for sure that it's, not an evidence? You only have so many prints, or, it has this very interesting moment where it has this cross-stepping gait where an extreme version would be something like a model walk where you're sort of
Mhm,
crossing one foot completely in front of the other. So it happens, and it's kind of odd, and it's one of the things that sort of definitely shows that this is a hominin because of the nature of our hips and our knees allow us to balance through that, where something like a bear simply can't do it. They don't have the anatomy. But also, it's strange. Like, unless we're playing or model walking down the street, we don't do that very often. So
right.
why is that happening in this individual? And so one of the things we want to do is go back to the site and try and expand those excavations beyond what was originally done in the
Mm,
70s and beyond what we did in 2019 to see if we can pick up this trackway on one end or the other and maybe find more prints from this individual, be fabulous if there were prints of other individuals walking with them. And so try and get some clarity about who they are and what kind of exact differences are at play between this individual and those that made the trackways at G and S.
wow. And again, just picturing, like the story you put in our heads where, these afferenses are walking across this field and then they look across and there's something else. That's just It's so exciting to think about. I mean, we have so much more information than we've ever had before in terms of who was where and what was happening. It's just amazing. Now, when we're talking about discussing a new species based on nothing but their footprint, what hurdles do you have to go through to get that accepted? That this is not what we already know it is.
Yeah, and it's a tricky thing, and it's one that has some sort of cautions applied to it
Mhm,
because it's only from footprints. It's only from five. They're from a juvenile individual, so it's hard. It would be very difficult to say this is X new species without a lot more evidence surrounding that. So what we argue in the paper, I think quite successfully, is mostly just that it is a hominin based on these mechanics about the way that they move, the proportions of the foot, about how it can actually sustain the gait that it uses through those five steps, and that it is inconsistent with these other fossil prints that we have all attributed to Afarensis, that they're largely given to that species. And so it's sort of unsatisfying because a lot of people want, like, so tell me who it is. Tell me who it is. Like, I know, I want to know too, but we need more information than we have for that right now. The best we can do is say, based on ontogeny, how we know things change as they grow. We can look at the G prints, the S prints. We can look at what happens in humans, both folks living today, and fossil footprints from a site called Ingarosera, which is made in a very similar circumstance, volcanic ash, and then what we know are anatomically modern humans who walked about 19,000 years old.
mm,
So compared to those, which is made by a whole bunch of people, so we know that there's individuals of all different ages there. Look at what we see in chimps. We can see that there's young individuals to old individuals. There's a line between those of sort of how you grow, and where you would expect A to B, if it's just a young afarensis, it doesn't fall there. So that is one of the things. Is like, okay, it doesn't makes sense with what we know about how these individuals likely grow. Obviously, we can't know that for sure, but we use our best models ourselves and our close living relatives to try and kind of see that there are trajectories to follow and that this doesn't make sense. It doesn't pattern in that same way. And when we look inside the tracks themselves, so how these prints were actually made, how did the motion of the foot, what exactly is going on with like how sticky outy is the big toe, how abducted is it, does it match with the mechanics of what we see in something like an afarensis? And it doesn't. So its foot proportions are wrong. It doesn't seem to be moving quite the same way. So our best thing we can do is like, well, it's not an afarensis and it is a hominin. And so that sort of gets us to this, it's got to be another species, because that's what we have. But I would, and so that's one of the things of like, how do you get some clarity on that, is ideally find new fossils that kind of help us connect those dots. What are the feet of Diremata look like? What are the feet of Kenyanthropus platyops look like? Oh, and if we can find more of these prints. So, okay, if you can have, an adult individual with very similar feet to A, what does that tell us? And can we see then what that trajectory in that group would look like, and sort of does that match up with something else as we find its anatomies and kind of make that make sense? So it's sort of, we've solved one mystery and set the stage for another one.
Which I think is how science works in general. So
yes.
So rewinding a little bit, you started out by saying, you had a feeling these were not Ursid footprints. These were not bear footprints. What was your hypothesis going in when you were formulating your ideas?
Yeah, so it's part of it was having then been working with these little bears some, that they do absolutely stand up. They are interesting, as we talked about, when they're bipedal, but that's not something they do frequently, and it's not something they do in the same way as Laetoli A. So when a bear stands up, they're either playing or they're displaying at one another, or they're standing up. I'm like holding onto a tree and I'm eating something off this tree. They very rarely walk anywhere. And so that was one of the sort of initial things that kind of made me, it's also weird that it's juvenile. The bears that are in this part of the world at that time are quite large bears. These are sort of grizzly bear, polar bear sized individuals.
Okay.
They're fairly big. And so this is Agratherium africanus. And so having a juvenile bear being alone was kind of an odd thing for me. Kind of, it's not impossible, but And then the other thing is, even when they first discovered them, they sort of said, well, we don't have any bear fossils here. But then we had 40 more years to find them. And they have found fossils of all kinds of animals. There's 85 mammalian species whose fossils are represented at Laetoli. And it's not impossible, I'll say, for you to have a species who's maybe represented in a footprint assemblage whose bones aren't. But typically the animals where that's true are things like birds. So I stop, I visit, I put down my footprints, and I fly away. And there's a reasonable explanation for why I may not show up in the fossil assemblage. It's not impossible, but there's no good reason why we would find bear prints and not bear fossils. So knowing that they hadn't found anything in that area as well also kind of, so I don't know, I was kind of thinking, certainly it's a hominin. I didn't have a predisposed thought about whether it belonged necessarily to G or not. It certainly looks different, just even if you glance, I don't know if you show the paper or anything like that. The when you look at the proportions of G and when we have a size match picture of A is just a lot wider. It just doesn't look quite the same. And there's certainly individual variation within species. So it was possible that would be kind of incorporated within that, but that just doesn't seem to be true when we sort of pick. Sorry, one of the analysis we did was looking at sort of populations of humans, and sort of if you pick any two humans to have a comparison, which is what we could do with our Laetoli prints, how different are they from sort of the average human, and you get a nice distribution for that. And you can do the same thing with chimps. How different are any two chimps from one another? If you use the G and S prints, they actually fall nicely within the distribution of modern humans. They're sort of not, they're within sort of a population, they're not as different as something like a chimp would be from what we see in humans. Laetoli A is as different from humans as a chimp print is. So they are very different in how their proportions are than something like afarensis, which we've seen that the afarensis feet and afarensis footprints tend to be a lot more human-like, even despite their age. And so this one kind of definitely falls even further out than perhaps we even expected when we started looking into them.
Which is just, again, just having another possible species out there that we don't know about is just amazing. And it's so exciting for anyone who's interested in this. It's just
makes
thrilling. And
makes our stuff, it's so cool, it's so complicated, and oh god, it's so complicated every time we add a new, it also makes our history more diverse, but a more complex story. And it is both a blessing and oh gosh, how does this all make sense?
most definitely. So we have these, they're not new footprints. We have these newly analyzed footprints, we will say. And because myself, guilty included, originally titled the article "New Footprints Found at Laetoli." They are not new, they are newly analyzed, but
Re-excavated, either one.
re-excavated. How did you end up actually there on this team doing this?
Yeah, so this project is the result of fabulous collaborations with a bunch of folks that kind of made this happen. So it sort of started with me in my office going, what is going on? And then I went to my advisor at the time, who's Dr. Jeremy De Silva, who was my advisor and is one of the co-authors on this paper, and sort of said, I don't think these are true. How do we kind of go about this? And then very quickly we went down the road and worked with Dr. Ben Killam and his sister Phoebe, who both work at the Killam Bear Center, to start looking at these little bears. And then kind of realized, all right, we're onto something. These bear prints don't kind of make sense with what we're seeing. So we need a larger comparative sample. And so that helped expand the team of like who has data on chimps. Some of that I collected myself, looking at some chimps at Ngomba Island Chimpanzee Sanctuary, which is in Uganda. But there's also several of our colleagues worked with the chimps. There were 2 individuals at Stony Brook University, which were a really good opportunity to get bipedal chimpanzee prints. So what do those look like when they act to stand up and walk? And so that kind of grew the team even more. And then as we realized, like, okay, there seems to be some evidence that maybe those Laetoli A prints weren't fully excavated. How do we go back and look at them? We can't seem to find any of these original casts. So the next step then was, let's go back to Laetoli and find them. And so that's where we reached out to Charles Masiba and said, we have a pretty good, reason to go back and try and find these and dig these up. And, we're worried about how they may be preserved. We don't even know if they still exist. And so then that prompted a fairly large team of folks to go actually to the field and do that. So over the course of the summer, I think it's 11 of us total. I myself was not actually one of the folks who went. I was busy teaching over the summer. But sort of Charles headlined the folks there, and I very much want to go back myself as soon as the world and the circumstances therein will let us do that.
Yeah. I'm sure that has put a damper in many much of field work. Yeah. So we have all this new information now and all these new hypotheses, obviously, and we're trying to figure out what made these footprints. We now know what it's not, as we discussed, and we know that we can't put a pin in what it is just yet.
Yeah.
Bar finding actual remains or fossils there, which reminds me of a question. So you were saying that there's haven't been any bear fossils found in the area. So how could there be a bear there? Have there been afarensis fossils found there?
Yeah. So
Okay.
yeah.
Okay, so, perfect.
I realize that sometimes people get a little confused about. I bring up Lucy because she's the most familiar, but Lucy's obviously not from Laetoli.
Right.
But they have found other material within that area. Yeah.
Okay.
Yeah.
That makes perfect sense now then. So, bar finding fossils of something else, how do you even begin to take the next step of saying what it was?
Yeah, I mean, we do kind of have to have fossils of something else. Whether they're precisely at Laetoli or not is sort of what may help. So if there are discoveries at nearby sites at the similar ages in Eastern Africa of something like a foot of Australopithecus dirameter, that kind of gives us the next question. All right, here's this foot, here's what its anatomies are. Do those make sense? Could those line up with what we're seeing in A? And sort of that becomes the next, like, how do we examine this? And so the same kind of thing is that whether they're found specifically at Laetoli or in that similar area, there's another, species of something completely different from what we already have right now. Do we have the anatomies preserved from that animal to kind of make that comparison? So that's it. It's kind of becomes a waiting game of, do we get lucky enough out of that difficult fossil finding moment to find it and sort of test.
So is it safe to say then, as far as within that locality goes, every future foot fossil that you find will need to be tested to see if it lines up?
Yeah, and it kind of has to be not just a piece of a foot, but you kind of need
Right,
a decent amount of a foot, right? So my dissertation things, I'm often interested in the calcaneus, which is the heel bone, but a calcaneus alone does not a footprint make, and so kind of have to have enough pieces to at least get some sense of like, well, how big is this foot? How wide is it? Does it have a divergent toe at all? To sort of how does it line up? So things like I mentioned that the Bertelli foot doesn't seem like a good match, and part of the reason is that we have enough of the anatomies of that foot preserved to see that it has things like a really long fourth digit, and so that doesn't match up with what we're seeing in the Laetoli A print, which is kind of without too much analysis why preliminarily that seems like a poor fit. So you kind of need enough pieces to go together to be like, all right, this is what that foot looks like, to be able to kind of, as he will, slot it into a footprint and be like, do you match? And it's like, well, okay, not so much in that case, but maybe this other fossil.
So we're waiting for that Cinderella moment.
Yes, it is absolutely. We're now waiting for the foot, and we have a shoe.
Wonderful. And just, oh, it's just so exciting. I can't get over it. When I heard, because Dr. De Silva made that tweet, and I emailed him, and I asked him if he could give me any hints on what was about to come out or anything. And he's like, I said it was in chapter 6 of my book. I thought that was a big enough hint. And I was like, oh shoot, I guess I have to reread the chapter 6. And I was so excited to hear what it was about. And then your paper came out, and I jumped on that really quickly. And I was just amazed that something like this, first of all, had gone unreanalyzed for 40 years. And again, yes, there are a lot of problems with getting back into the field and everything, of course. And as we know, Africa is it can be a difficult place to get to and work in, depending on what's going on. So, I understand, but just when I finally heard that that's what it was, I was so excited. And now, I shot another email to Dr. Silva. I was like, can you get me an interview real quick? and I'm so happy that we're here chatting right now. And
I'm delighted it captured people. I think footprints capture people's imagination more than anything else. Because obviously what I do, what my colleagues do, I get really excited about like a piece of a femur and things like that. And it's really cool and it tells us cool things. But to the sort of like, if you're just kind of following along, you're like, okay, it's a little scrap of a bone. It doesn't necessarily mean as much to me. Where something like a footprint is just, I don't know, they capture the imagination in a way very few things do. And so I love them. And
yeah.
Yeah, I'm sure this is, full credit to the folks from the 70s. They're sort of working with their best knowledge at the time. The fossil record hadn't shown them that there were more to, they hadn't had that opportunity yet. And sometimes, I mean, this is one of the most amazing things about science and its collaborative nature. This moment of like, let me go back and think about this thing again, knowing now what I know or what's available to us or what the technology is available to us that wasn't there. I did this, one of my first papers as a grad student. I went to go look at fossils for the first time, and I was in the museum in the Evolutionary Studies Institute in South Africa, looking at fossils there. And I looked at a calcaneus, this bone that has been known for quite a long time. And I was looking at it, and I went, I think this this anatomy of it is broken. And I was like, people have been looking at this for 10 years. I'm wrong. But of course, I sort of like shuffled in to be like, hi, advisor, am I? And he kind of told me after, he's like, whatever, I shall look at it and I will tell you why. Oh, no, you're right. And someday someone will go, hi, I'm going to tell this, and I will think, haha, I know everything. And then I will be wrong, and they will have seen something that I didn't see, because that is the amazing nature of our science, of like new perspectives, new eyes, new time, all of those work together to let us kind of build a more complete story. And it's one of the things that makes me love doing this, because I look very much forward to the day where I'm like, well, that is awesome, and I was so wrong, and I missed that, and I can't wait for you to tell me more, because this next chapter of somebody being able to see cool things. So it's
100%. And I think that's a great thing about science, that it's splendid. That chance of a new pair of eyes seeing something that was never seen before.
Yep.
And it's truly amazing. Now, is there anything that you would like to impart on our viewers, whether they be students looking to get into the field, whether they're fellow researchers, anyone?
Yeah, I guess my pathway to doing this is a little circuitous. I actually started kind of college planning to be an engineer. I went to be a materials engineer, which is less how do you build a bridge and more what do you build a bridge out of. And I was a good engineer, but I didn't love it every day, and I kind of was like, and I, by happenstance, had encouragement from my peers, from my family, and things like that to be curious about the world and to just do other things as well for fun. And so I worked in a research lab that was looking at muscular dystrophy and things. And I was like, actually, squishy biology is amazing. Why have I not been doing that? And then I took anthropology for fun. I just took a class because I liked it, and I thought that was cool, and I wanted to know about us. And I happened to be lucky enough to sort of watch a documentary in that class that said, here are tibia from a modern human, and from Lucy, and from a chimpanzee. And if you look at the bottom of them, humans are square because we put forces pretty evenly through our feet when we walk around. Chimps are trapezoids. They're bigger at the front because when they climb, all this weight goes to the front of their legs. And if you look at Lucy, she looks like us. She looks like a person. She looks like human. And it's because she's moving in a similar way. And I was like, oh my God, you can tell their motion. And it's like engineering, but with biology and all these things. And it sort of like blew my mind and set me down the path of doing what I do now, because I was in the right class doing something that was fun, even though it kind of didn't make the most sense for the thing that I was doing at the time. So reading books, watching things, taking classes that are kind of outside of, what I have to do to get where I'm going are fabulous. You learn something cool, and they may set you down a path that ends up being, amazing and wonderful. So that's, I guess,
definitely,
my plug for humanities.
I definitely have to agree with what you said there about starting somewhere completely different. I started out as a deaf studies major, learning sign language to be an interpreter, and I chose biological anthropology as a elective, and never looked back.
I know, it'll get you.
Definitely. So once again, I just want to thank you so much for joining us, and it has been an absolute pleasure having you on here. I know we just went over, your advice or anything, but is there any parting words that you would like to give on anything besides what you just had? I know I'm kind of double whammied you right there.
No.
Okay. Okay. That is perfectly okay, because I guarantee there will be more amazing discoveries coming out from you and your colleagues, and I'm sure we will have you on the show again as soon as those come out, because this was so much fun. And I just want to thank you again. And I have to thank Dr. De Silva for getting this interview and everything else that he does for me and everyone else that he helps. So huge shout out to him, and a huge shout out to you for agreeing to come on, and the amazing work that you and the team have done on this paper and everything. So thank you, and we'll see you soon.
Sounds lovely. Thanks for having me.
Thank you for adventuring with us into the human past. If you've enjoyed this video, check out our website at www.worldofpaleoanthropology.org and find us on Facebook, Twitter, and Instagram.